Today is 2nd of April 2025. We did Wireshark lab from 1 to 15. What we did first is that there was some virus that we should use from download text and upload it. When we upload it, you should push the blue button of Wireshark. So you should record it. Then after that, what you can answer from question from 1 to 3. Basically from question 1 to 3. And yep, you can see the packet and packet info. With the TCP, and maybe if you want to check the Wi-Fi, then you can check the DNS. So I checked the source IP and source port. And also, when first communicate each other, I check the flag. So I check sync number is set to 1. And for the from first problem, it was about checking. We download another trace.zip, and there was problem that was not able to open, so we just changed the file format. After that, we did for the number 4. We did in 4 is check sequence number of TCN segment that is used to initiate TCN. So we check sync number, and it was also set number 1. And number 5, it was about checking also sync neck. And what is the value of it? We check it in flag. Basically, sequence number starts as 0. And for number 6, what is the sequence number of TCP segment containing the HTTP post comment? In this case, what we did is, if you go to sequence 1, then if you go behind, then this is first sequence 1, ACK 1, which is from sender to receiver. There you can see post. After that, the sender is sending maximum amount, a lot of 565. After that, they send 1460. They send a lot. They send a lot. They send a lot. And 8. This is about frame 5. Receiver is returning, so you can check. Also, return RTT return time. This is about 5. And this is about send again. This is about return frame 7. And this is about return frame 8. And there's return frame 10. And there's return frame 11. And there's return frame 13. In this case, everything is returned, but later, at some point, there is a sender sent packet, let's say 20 and 21, but receiver just only return the packet 21. That is, we call that situation as ACKing. In case many packets received close together, then receiver just send only one packet. This is different with fast transmission situation, which is in case of packet loss, they assume packet loss. And for 7, the first connection was TCP connection. We saw the sequence of numbers of packets, and also we saw the RTT. We can calculate estimate RTT by average exponential averaging method, like alpha multiplied by RTT sample 1 plus 1 minus alpha, RTT sample another, and plus again and again. And for what's the length of each of the first 6 segments? We check the length at here basically. And if you see the first part, there is length is 0, 0, 0. And here x is 1. X is 1 and length increase. And after that, x become length and sequence, sum of length and sequence. And later then you can also calculate the base left byte received, and also SendBase and variable y. I will discuss it next time. And minimum buffer of buffer space. You can also check in using statistics to go time sequence to checking switch direction. So from sender to receiver, the format, how it increased. If we zoom this, then we can see there was flow start. And for retransmission, in this situation, we checked there was no retransmission based on there was no graph that goes, there was no congestion control. And for how much data does receiver acknowledged is based on when it goes stable, its length is 1460. So we assume that 1460. And for the throughput, we calculate throughput, average throughput by 3/4 multiplied by some value over RTT. Some value is what was the some value for?
Bytes in flight.
Bytes in flight. And after that, yeah, using time sequence graph, we already saw time sequence graph. So next time we will come back with the relationship between receive byte and acknowledge number and send base and y. Thank you very much.